Welcome to the AI Checkpoints. Today, we're really diving deep into something that keeps coming up: context engineering. It feels like this is becoming, the key differentiator between AI that looks cool in a demo and AI that actually works reliably in the real world. We've been digging into insights from some really sharp minds, folks from YC Root Access, like Dex from Human Layer, Jeff over at Chroma, and Jake, the founder of CoCounsel. These guys are in the trenches building coding agents, legal AI, optimizing how AI gets information, and they're sharing what actually works to make models dependable, especially for, complex production level stuff. Not just toys. It's kind of like the secret sauce, maybe, for really unlocking what these large language models can do, and you need precision.
Yeah, and what's really fascinating, I think, is how they're all converging on the same core idea, even from different angles, whether it's building agents or figuring out the best way to retrieve data or making an AI lawyer. They all land on this, how absolutely critical it is to manage the information the AI sees. It's so much more than just asking the right question. It's about giving the AI the right world to operate in, basically.
Right. The right world. So, what does this actually mean for you, whether you're like deep in development or just trying to figure out where AI is genuinely useful today?
Let's unpack it. Okay, first things first, terminology. Jeff from Chroma makes a pretty strong argument for using context engineering.
Yeah.
He says it's better than just prompt engineering or even RAG. Why is that distinction important, do you think? Well, Jeff's perspective, as I understand it, is that AI systems are fundamentally programs. Sophisticated ones, sure, but programs. So the output you get, that kind of magic response, isn't magic at all. It's dictated by the instructions, the data it sees, the tools could use, and yeah, the user's input. So context isn't just the prompt, it's everything in that window. That includes stuff pulled in via retrieval augmented generation, RGA. It's a much wider lens. It's about engineering the whole input package, not just the request.
That makes a lot of sense. It's the whole environment. And Dex from Human Layer, he builds on this, right? He calls LLMs pure functions. What's the implication there?
Yeah, that's a really helpful analogy from programming. A pure function always gives the same output for the same input, and it doesn't mess with anything outside itself. So if you think of an LLM like that, it means the output quality is just directly tied to the input quality, full stop.
Yeah.
Dex really hammers this point. Beyond the initial model training or fiddling with settings like temperature, the only thing that reliably improves the output is improving the context. So the big question becomes, if context is king, what makes context good? And how do you actually engineer that?
Okay, but hang on. We hear about these massive context windows now, right? Anthropic's got 1 million tokens. Others are talking 10 million. Doesn't that kind of solve the problem? Just dump everything in?
You'd think so, wouldn't you? But
Yeah.
Jeff's research at Chroma, they actually did a technical report on this. It shows the opposite. It's pretty surprising, actually. They found that performance, even on simple things like just repeating words accurately, it actually drops off, sometimes sharply, as you cram more and more tokens into the input.
Seriously, so bigger isn't automatically better?
Not at all. In fact, it can be actively counterproductive if you're not careful. Just having a huge window doesn't mean the model can effectively use all that information. It can get lost, confused, performance degrades. It really highlights that it's not about the sheer volume, it's about the relevance and the clarity within that volume.
Wow. Okay. And that's not just for simple tasks, right? This applies to complex coding too. Dex pointed out some real hurdles there.
Oh, absolutely. Dex's experience, especially with AI for coding, shows there's often a ton of rework needed. He mentioned a Stanford study that found developers were chucking out like up to half of AI-generated code
Half. Why so much?
because it was often sloppy, he said, or just not suitable for really complex systems or what they call brownfield projects, big, messy existing code bases, trying to get AI code to play nice with decades of maybe undocumented legacy stuff. That's tough. So sometimes it actually ends up slowing the human developers down because they have to fix or rewrite so much.
Right. So the idea of just telling an AI, write my entire production app, that's still science fiction, basically, at least for now.
Yeah, pretty much. Amjad from Replit made a similar point. Great for prototypes, getting something up quickly, but for those big, gnarly production systems or integrating into massive existing code repositories, they're not quite there yet. Which, again, brings us back to, if these models struggle with just raw data dumps and complex tasks, what are the strategies that work? How are people like Dex and Jeff actually making this useful?
Okay, so let's get into the solutions. The good news is they have found ways. Dex, for example, he talked about dealing with these insane 20,000 line pull requests of Go code generated by AI. I mean, how do you even review that?
Exactly. You basically can't, not effectively. And that pressure forced his team at Human Layer into a whole new way of working. They call it spec-first development. Instead of trying to review the mountain of code, they shifted their trust to the specifications before the code gets written. They aim to keep the context the AI uses under, say, 40% of the window, and they have this really structured three-step process: research, plan, then implement.
Okay, break that down. Research, plan, implement. So the AI first has to figure out how the existing system works.
Precisely. It has to really understand the current state, look at docs, look at the code. Then phase two, planning. It has to explicitly lay out every single change it's going to make, and crucially, how it will test those changes. Only after that plan is approved does it move to phase three and actually write the code. It's very deliberate.
And the human review happens where in that process?
This is key. The humans review the research in the plan, not the 20,000 lines of code. Dex's point is that a mistake in the research or a bad assumption in the plan that can cascade into thousands of lines of wrong code. So the human step is about catching those fundamental misunderstandings early. It's about mental alignment, as he put it, before the AI goes off and builds the wrong thing. It makes intervention much more effective.
That makes perfect sense. Engineer the workflow, not just the prompt. And this focus on precision, on getting the right information in front of the AI, that sounds a lot like Jeff's gather and glean idea from Chroma.
Exactly. Jeff's model is all about optimizing that context window. Gather is the first step. Maximize recall. Pull in everything that might be relevant, from databases, APIs, web searches, chat history, wherever. Cast a really wide net. But then comes the crucial second step: glean. Maximize precision. This is where you carefully filter out all the noise, all the irrelevant stuff, to create a clean, focused, highly relevant context for the model.
Okay, gathering sounds straightforward enough. Cast a wide net. But how do you glean effectively? What are the techniques for that filtering part?
There's a range. You can start with simpler things like vector similarity search, or techniques like reciprocal rank fusion to combine search results smartly. Then you get into more advanced stuff like learning to rank systems trained specifically for relevance, or even using smaller, faster, cheaper LLMs just to do the curation read through potential context and summarize or pick out the key bits. This is also where you see things like subagents, which Dex mentioned too. A main agent can ask a specialized subagent to go find information, and the subagent just reports back the concise answer, keeping the main agent's context clean, like delegating research tasks.
Delegation for AIs. Interesting. And Jeff had that really weird finding about learning, didn't he? Something about failures versus successes.
Oh yeah, that was fascinating. He found that giving an agent access to examples of its past failures actually helped it perform better. It seemed to help it recognize and break out of common failure loops or traps it might fall into. But counterintuitively, feeding it examples of past successes often made it perform worse.
Worse. How?
It seemed to lead to kind of lazy pattern matching. The AI would just try to mimic the successful example without really understanding the nuances of the current different problem. So learning what not to do was actually more beneficial than just copying what worked before. It's like us learning more from mistakes sometimes.
That is wild. Okay,
Yeah.
shifting slightly but still on this theme of meticulous engineering, Jake from CoCounsel. He's applying this to the legal world, which has its own complexities.
Right, Jake's team built CoCounsel by first thinking about the ideal outcome for the user. What does a great legal research experience look like? What about contract review? Then they mapped out how, theoretically, the world's best lawyer would actually do that task step by step. They broke it down into what they call microsteps. Each tiny step is then handled either by traditional code or by a very specific, carefully engineered prompt for the AI.
And he described a really intense process for developing those prompts. It sounded less like guesswork and more like, well, engineering.
Totally.
Ah.
Super rigorous. They start with an initial guess for a prompt, then immediately test it with maybe 10 different real-world examples. The key is they don't move on until that prompt works perfectly for all 10 examples. They iterate relentlessly right there. Only then do they scale up the testing. 50 examples, 100, eventually aiming for 1,000 tests. They're constantly trying to anticipate all the weird, crazy ways a user might phrase something or the oddities in a document that could trip the AI up. It's about building robustness through testing.
And Jake also really hammered home the point about checking the actual context the AI gets, not just the prompt you wrote.
Oh, hugely important. He said so many times they thought they had a prompt problem, but when they looked closer, it was actually a retrieval problem. The AI wasn't getting the right background documents, or sometimes even an OCR problem. The scan of the legal document was just messy. His advice was gold. Read the AI's input exactly as the AI sees it, spaces and all. If it looks confusing or hard to read for you, it's definitely going to be hard for the AI. And he also strongly advised instructing the AI, like explicitly. Only answer based on the documents provided. It's a simple instruction, but apparently very effective at reducing hallucinations.
Simple but effective. Did he share any other kind of pro tips or tricks?
Yeah, a few neat ones. For speed, he suggested designing prompts where the most critical part of the answer is right at the beginning. Maybe just single word or token like a number, or true, false. Then you can just cut off the generation right after that token comes out. It forces the AI to do its thinking up front to produce that concise answer. He also talked about breaking tasks down, using reinforcement learning fine-tuning on small data sets. Just 50 or 100 examples per microstep can make a difference. And even using different LLM models for different parts of a complex workflow. Maybe a powerful one for analysis, but a cheaper, faster one for summarization to optimize cost and performance. Very pragmatic.
Wow. Okay, so taking all this in, this deep dive really paints a different picture of AI development, doesn't it? It's not just about waiting for the next biggest model or throwing more data at the problem. It's really about this intelligent, meticulous management of the information, engineering the context. It feels like a real shift.
It absolutely is. And the message from Dex, Jeff, and Jake is incredibly consistent, even though they work on different problems. The focus has to move from just tweaking prompts to this broader idea of context engineering.
Mm.
That means thinking about the whole workflow, how you curate data, where humans intervene, and this constant cycle of testing and refining. Dex actually thinks that changing the workflow, how teams operate, will be the hardest part for organizations adopting AI. Harder than the tech itself. It's about changing human habits, too.
And when teams get this right, the results can be pretty stunning. Like you mentioned, Jake's CoCounsel hitting the 90th percentile on the bar exam, that's serious performance, enabled by this kind of engineering. It lets AI tackle these really complex production problems like adding WASM support to a language or fixing huge code bases stuff that seemed impossible not long ago. The reliability comes from that engineered context.
Exactly. So the question this leaves us with, really, for anyone listening, especially if you're working with or relying on AI, how are you going to adapt? How will you rethink your own processes, your workflows, your intellectual habits to get good at feeding the AI just the right information? Because that seems to be the key to unlocking its reliable potential. The revolution isn't just the AI model itself, it's in how we learn to effectively interact with it, how we engineer that interaction.
A really powerful thought to end on. It's about engineering the interaction. Well, that's all the time we have for this deep dive on context engineering. Thanks for tuning in. Hit like and subscribe if you like the content. We appreciate it. See you next time.